Hello and welcome to my walkthrough of a Grover's algorithm question. We're going to see how Grover's algorithm can be used to amplify the amplitude of a marked state. Let's have a look at the question. So an example question might be, by using the example of a 3-qubit register, i.e. 8 elements to search from, and making your own selection of the marked element, find how much 2 iterations of Grover's search algorithm will amplify the amplitude of the marked state relative to the others. So we, in this situation, have 3 qubits, so 8 possible states. This is just our numbers from 0 to 7 in binary, for example. We're going to say that the number 7, aka 111, is the marked state. So the steps for Grover's algorithm is first to initialize the n-qubit state in a superposition, then apply the oracle, which will impart a phase flip on the marked state, apply diffusion, which will reflect about the average amplitude. Then we're going to rewrite the normalized state, repeat as many times as we need, so in this case 2 times, and then we're going to measure the state and we're going to see how likely we are to get the marked output. So the first thing we're going to do is we're going to set up our superposition. That's easy. It's just an even distribution over all the possible states. So we give it each of them get a coefficient of 1 over root 8. Now we're going to apply the oracle. This is going to flip the marked state, and our marked state is our 111 state. So our coefficient in front of that becomes negative. Then we're going to apply the diffusion operator. This is going to reflect about the average of the amplitudes. So our average amplitude is just the sum of all of our amplitudes divided by the number of our amplitudes. So we have 7 examples of 1 over root 8, so we get 7 over root 8. And then we have one example that is minus 1 over root 8. So we add those two together and then we divide by 8 because we have 8 states. And this gives us an average amplitude of 3 root 2 over 16. Next, we're going to reflect about each of these amplitudes. So a reflected amplitude is equal to 2 times the average amplitude minus the input amplitude. And this just comes from taking the difference between the input amplitude and the average amplitude and then adding it to that average amplitude. So for our first state, we can put in our average amplitude and our input amplitude of 1 over root 8, and we get root 2 over 8. Now, for all of the rest of them, nearly, this is exactly the same because they all have an amplitude of 1 over root 8, with the exception of our marked state, which has an amplitude of minus 1 over root 8. So this gives us a reflected amplitude of 5 root 2 over 8. Next, we're going to rewrite our normalized state with all of our new coefficients in front of our states. And we're going to repeat the steps. So the next thing we're going to do next is we're going to set up our superposition. So here we've taken a factor of root 2 over 8 out. See, already you can see that the amplitude of our marked state has increased quite a lot, but we're going to do this again, increase it even more. We're going to apply the oracle. So we're going to flip the sign of the marked state. This is again 111, so we have a factor of minus 5 in front of our 111 marked state. Then we're going to apply our diffusion operator. So again, our operator reflects all the amplitudes about our average. Our average amplitude is a new average amplitude because we now have 7 examples of root 2 over 8 and 1 example of minus 5 root 2 over 8. We still have 8 states, so we still divide by 8 and we get our new average amplitude of root 2 over 32. Next, we're going to reflect about each of these amplitudes using that little equation we managed to come up with earlier. So for our 0, 0, 0 state, we have an amplitude of minus root 2 over 16. And this is the same for all of the other states except for our marked state, which has a much larger amplitude of 11 root 2 over 16. So now we're going to rewrite our normalized state. And here we are with all of our coefficients in front of them. There are minuses, but that's not a problem because when we take the probability of getting the state, we square the amplitude of that state. So, for example, the probability of taking the 0, 0, 0 state is minus root 2 over 16 squared, which is about 1 over 128, 0.8%, not very likely. But when we take the square of our marked state, which is 11 root 2 over 16, we have a much higher probability of getting that state. So we've had a very large increase in our amplitude after just 2 iterations of Grover's algorithm. I hope this makes sense. If I have made any mistakes, do let me know, and please do ask any questions if you have any. Thank you very much for watching.